In this video, we are going to see secondary voltaic cell. The example what we are going to see here is a lead accumulator. Now, what is a lead accumulator? To understand that better, let me take an example of the cell what we use at home, and that is the emergency light. All of you have emergency at your house. It works on the principle is, what you do is the first process is you pass electric current into it, where the electrical energy is passed through the cell. Now what actually happens is, in the cell there are chemicals, and because of them the chemical reactions takes place. When the chemical reactions takes place, this converts this into chemical energy, and this chemical energy continuously gets stored within the device. When the charging process is over, you cut off this source of energy. Now students, the device or a cell that works where the electrical energy is converted to chemical energy, we call such cells as electrolytic cells. And the process here is called as charging of the cell. Once the charging is over, what you do is you use the emergency light for your other or different purposes. During this purpose, the chemical energy gets converted into electrical energy. Now, if I call this process as charging, what you will call this process is discharging of the cell. Here, if you see, the chemical energy gets converted to electrical energy. Such devices that converts the chemical energy into electrical energy, you call them as galvanic cells. Students, the cell or a device that works on the principle of charging and discharging, we call them as accumulators. Now, what are accumulators? Their principle here, that is charging and discharging. Depending upon what type or what material of the electrodes you use in the cell, we name them in a different way. Here in this cell, I will be using lead plates, and so this is the example what we will be studying is a lead accumulator. To understand lead accumulator better, let us see what the cell consists of. So let us draw the diagram. You can draw this along with me. Diagram is very easy and you can practice it. This consists of a vessel which is made up of acid-proof substance. So this I will call it as acid-proof vessel. Now the question is, why you need an acid-proof vessel? We need an acid-proof vessel because I will be putting H2SO4 in the cell as an electrolytic solution. Here I have used plates which are alternately placed as anode and cathode. Here I have used 4 plates. You can use 2, 4, 6. So it should be an even number of plates what you are using here. The cell is filled with H2SO4 solution. Mark this, student, the cell working is totally or completely dependent upon the concentration of H2SO4 here. Now this H2SO4 what I am using is the electrolytic solution, its concentration is 38% and its specific gravity or density is 1.2 gram per ml. It's very important to note that the H2SO4 specific gravity must be maintained to 1.2 gram per ml to get a good electrical output. Now here, if I see the first plate and the third plate, I will connect them as the negative terminal and I'll call this as anode. The second and the fourth plate, I'll connect them as the positive terminal and I'll call them as cathode. Now, what the first and the third plate is made up of? The first and the third plate is made up of lead packed with spongy lead. Now, what the cathode is made up of, that is the second and the fourth plate, they are also made up of lead, but they are the lead plates packed with lead oxide, that is PbO2. Very interesting to note, although this is a galvanic cell, there is no salt bridge which is used here, and the plates, they are in direct contact with each other with H2SO4. Now, let us see what the working is. The cell reactions, they will consist of charging and the discharging of the cell. So let us see the discharging reactions first. There are some simple tricks what we will be using to remember the cell reactions. Very important, students. The electrolytic solution what I am using here is H2SO4. So first I will write 2H2SO4 will give me, I am using here 2 moles of H2SO4. It will give me 4H plus plus SO4 2 minus. Wherever you have some ionic forms, please consider the physical state as aqueous. This is liquid, what I am using. So this is the first reaction. Let us see the reactions during the discharging of the cell. Whenever you write the cell reactions, it is very, very important that you should mention the electrode and its polarity. So here at anode, what is the polarity? It is negative. What the anodic plates, they were made up of? Lead. So the first reaction will be Pb will become Pb2 plus 2 electrons. If you see this, here there is loss of electrons. So what you will call this? You will call this as oxidation. Next, this Pb2 plus will now combine with one of the sulfate ion from here, and I will get PbSO4, that is a precipitate. PbSO4 is solid. So this is called precipitation. So two-step reaction, oxidation followed by precipitation. Now if I try to add the two equations, what will get cancelled is lead and lead. So what I will get is Pb solid plus SO4 2 minus aqueous gives PbSO4 plus 2 electrons. Right, student? So what type of reaction is this? This is oxidation at anode. Let us come to the other terminal, that is cathode. At cathode, what is the polarity? Positive. What the lead plates, they are packed with? PbO2. So at cathode, the first reaction will be PbO2 plus. All the 4H plus from here, they will get added. 4H plus. This is a reduction reaction taking place at cathode, so it must gain the 2 electrons lost here. And what I will get is Pb2 plus 2 moles of water. What is this reaction? Is reduction. Again, Pb2 plus will combine with the remaining SO4 2 minus ions, and it will give me PbSO4. This is precipitation. You find here reduction is again followed by precipitation. Let us add the two equations. What will get cancelled again is Pb2 plus. So what you get is PbO2 plus 4H plus ions plus SO4 2 minus plus 2 electrons gives PbSO4 plus 2H2. This is what? This is reduction at cathode. Right, students? So I got oxidation, that is this equation, equation 1, and this equation as equation 2. If I want the complete redox reaction, what I need is I must add anode and cathode reaction. So I am cleaning this because of space, and I will add the two equations now. So here I have the first equation, that is at anode. Final equation I am writing. This is the negative terminal. So what I have here is Pb plus SO4 2 minus gives PbSO4 plus 2 electrons. This is your oxidation reaction. And I will write now what happened at cathode. So let us write the cathodic reaction also. So at cathode, this is the positive terminal. Very, very important to mention the polarity. So PbO2 plus 4H plus SO4 2 minus plus 2 electrons gives PbSO4 plus 2H2O. This is reduction. Let us add the two equations now. Very interesting to see. Now if I have H plus and SO4 in the ratio 2:1, what I can form is H2SO4 molecule. What all things will get cancelled here, students, is only 2 electrons. So let us write the equation. Pb solid plus PbO2 solid plus. Now if you add this, see this is one sulfate, this is other sulfate. So I will get 2SO4 2 minus plus 4H plus will give me, if you see this, there is SO4, PbSO4 and PbSO4 2 moles. So I'll get PbSO4 2 moles plus 2 moles of water. Right, students? This is the equation. Now, if I combine them, what I will get is Pb plus PbO2 plus 2 moles of H2SO4 gives 2 PbSO4 plus 2 H2O. Now, this is your final equation. Now, what you observe here, this is the discharging reaction, students. H2SO4 gets converted to water. What it means? That H2SO4 concentration, it decreases. And when the concentration of H2SO4 decreases from 38% to lower to value to that, what happens is the potential of the cell, that is from 2 volt, it decreases down, and therefore the cell requires charging. Now, it's very, very important to note that during the discharging of the cell, what is happening? H2SO4 gets consumed. So, what it means, when I will charge the cell, H2SO4 should get regenerated. Now, let us see what the charging reactions are. For that, students, just listen to what I say carefully. Now, when I take the charging of the cell, as I have explained, the cell acts as an electrolytic cell. Now, what is the meaning of electrolytic cell? In electrolytic cell, anode is the positive terminal, while cathode is the negative terminal. Now, students, what you have to do is, I will write the first reaction here, that is anode. What is the polarity here? Is positive. You have to go back to the discharging reactions and see which electrode is positive here. If you note that cathode is having the positive polarity. So, students, what you have to do is simply reverse the reaction. So, what I will get at anode here is PbSO4 plus 2H2O gives PbO2 plus 4H plus SO4 2 minus plus 2 electrons. This is what type of reaction? This will be your oxidation now, because here the electrons, they are lost. Come to the second one, that is at cathode. What is the polarity of cathode here, student? Is negative. Go back to this. Which electrode is negative here? Is anode. Simply reverse the reaction. So it will be PbSO4 plus 2 electrons gives SO4 2 minus plus Pb. What type of reaction is this? Is reduction reaction. Right, students? I have just reversed this particular reaction. So, let us see what you get after adding the equations. What will get cancelled here is the electrons only. Now, let us see what you get. You get 1 and 1, that is 2 moles of PbSO4 plus 2 moles of water gives PbO2 plus Pb plus this one and this one, that is 2 moles of SO4 2 minus plus 4H plus. As I told you, this will combine and give me H2SO4. So what I will get here after combining this is 2 moles of H2SO4. So I will write here 2 moles of H2SO4. Now what you see, this is your charging reaction. So what happens here? Water gets converted to H2SO4. Means what is happening during discharging? What the specific gravity or the concentration of this H2SO4 has fallen down, that is regenerated, or it is maintained. So during the charging, what happens is H2SO4 is regenerated, while during the discharging, H2SO4 is consumed. So it's very, very important to note that the working of this cell accumulator completely is dependent on the concentration of H2SO4. So students, please, if you like the video, please like, subscribe and share the video, please. One more interesting thing is, we'll be seeing similar types of tricks to write the cell reactions for other cells. So please watch the next videos. Thank you.